Lesson 3.5 for algebra is similar figures. So it's proportions and similar figures. In the diagram, A, B, C, and triangle FGH are similar. This is in your book. Similar figures, here's what I want you to have in your notes. Similar figures, keyword, have the same shape but not necessarily the same size. The symbol, this is like a swirly mark, means is similar to. So make sure you have both of those things written in your notes. Now here's A, B, C, and D, E, F. They're similar figures, however, they're not the same. They're not the exact same. They are similar figures. So it says it right here. Triangle ABC is similar to triangle DEF. So find DE. So now I have this that I'm trying to find. And how I do this is I'm going to set up a proportion. So I know what A to B is. That is 27. And I'm going to put that over 32, which is C to B. Now, if I look at my similar figures, A to B is the same as DE, which I don't know what that is. And CB, right here on the bottom, CB is the same as FE, which is 24. So now I've just made a proportion. I can take off these labels, put it equal to, and then I can solve this. So I just do 27 times 24, and I get 648 equals 32x. I divide both sides by 32, and I know that x equals 20.25 centimeters. Do not forget your unit. Which x is this? 20.25 centimeters. All right, a dilation is a transformation in which a figure and its image are similar. So it gets bigger or smaller. The ratio of the dimensions of the new image is to the dimensions of the original figure is called the scale factor. So make sure you have both of these written in your notes, key concepts. To find the image of a figure in a coordinate plane with the origin at the center of the dilation, you multiply the x and y coordinates by the scale factor. So, dilating figures on a coordinate plane. Quadrilateral PQRS has vertices, and then they give them to you, and it's dilated by a scale factor of 1/2. The origin is in the center of the dilation. Graph the original figure and its dilation. So, pretty simple. What you do, if you notice here, they took the point P, which is -2,4, which is right here. That's -2, 4, and they multiplied it by the scale factor, which was 1/2. Scale factor of 1/2. Half of -2 is -1. Half of 4 is 2. So my new point P is -1, 2, which is right here. And it's called P prime, remember, with the little tick mark. So they did that in blue on all of these points, and then they have a whole new kite figure, quadrilateral. So let's try one on our own. MNP has vertices, MN and P, it gives the points. Graph the triangle and its image after a dilation with a scale factor of 2. So, draw a graph on your paper. We're just going to do this without graph paper right now. Unless you have graph paper, you can use it. So M is over 3 down 2. N is over 3 up 5. That's N, 3, 5. And P is -4, -1. So, a scale factor of 2. Now, I'm going to connect my points, M and P. Scale factor of 2 means I'm going to double each of these points. So, that means I need to get way bigger on my, okay? I'm going to double n. I'm going to have n should be at 6 comma 10. So I go over 6, up 10, and I'm about here, so that's n prime, 6 comma 10. M is at 6, 4. M prime is at 6 comma 4. I can connect those. And then P is at negative 8, negative 2. There's negative 8 and here's negative 2. So that's P prime. Negative 8, negative 2. So what I did is I dilated that triangle, MNP, and I made it a scale factor of 2. All right, applying similarity. A tree casts a shadow 7.5 feet long. A woman 5 feet tall casts a shadow 3 feet long. The triangle shown for the tree and its shadow is similar to the triangle shown for the woman and her shadow. How tall is the tree? So, similar figures again. I have two triangles. I have the woman is 5 feet tall. So I'm going to put her over her shadow. So I put 5 over 3, and that becomes one side of my proportion. And then I don't know what x is, so that's going to go with the woman's height. And then the other shadow goes on the bottom. Now I have a proportion again. I do 5 times 7.5, which is 37.5, equals 3 times x. And then I divide both sides by 3. And I see that x equals 12.5 feet. So that means the tree is a 12.5 foot tall tree. All right, a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. Floor plans, blueprints, and maps are all examples of scale drawings. The ratio of a distance in the drawing to the corresponding actual distance is the scale. So make sure you have scale drawing down in your notes. The scale of the map at the left is 1 inch to 10 miles. Approximately how far is it from Valcaria to Wabasso? Okay, so I have a scale. I'm going to put that here first. Okay, that's my first part of my proportion. So how far is it from Valcaria, which is right here, to Wabasso, which is right here? Now I look at my ruler, and I have 1 inch, and then I have 0.75. So it's 1.75 inches, and I don't know what the miles will be. So that's how I set up my proportion. I do 10 times 1.75, which is just 17.5, equals 1x, and then I divide by 1. So it is 17.5 miles. So then this one, on the map above, measure the map distance from Grant to Gifford and find the actual distance. So try that one, and then we'll go over it. All right, so you still want your 1 inch to 10 miles as your first proportion. Now, Gifford is here, and Grant is here. So I know, if I look at this, that if I go to here, that's 1 inch right there. Okay? And then if I go here, that's 2 inches total. So I have 2 inches over x. So then I have 1x equals 20. So x equals 20 miles. All right, that's it for your notes.